The simulation was supposed to take weeks. It finished in 9 minutes. Inside NASA's Quantum AI lab, the final report on interstellar object 3I Atlas flashed on screen and a stunned silence fell over the room. This visitor, which is currently making precise flybys of Mars and Venus, was already breaking the laws of cometary physics.
Right now, a few days ago, on October 3rd, it passed near Mars within 29 million kilometers.
But the AI's map of its internal structure delivered a far more shocking verdict. This thing isn't just a rock from another star, it's something else entirely, and its perfectly planned path through our solar system is no coincidence. Red flags in the void. On July 1, 2025, the Atlas telescope in Chile's Rio Hurtado Valley flagged a moving object, a faint point of light cutting across the starfield at a steep, unnatural angle. At first, it looked like just another minor planet, but within hours, observatories across 3 continents confirmed the same chilling fact. This was no ordinary comet. Its path was hyperbolic, meaning it wasn't bound to our sun. In fact, it was barely being affected by the sun's gravity at all. The calculated eccentricity was over 6, a number so high it shattered the record set by previous interstellar visitors. The thing nobody tells you is just how fast this object, now named 3I Atlas, was moving. It was racing through our solar system at over 130,000 miles per hour. That's fast enough to travel from New York to Los Angeles in just over a minute. By the next morning, it was official. 3I Atlas was only the 3rd interstellar object ever confirmed, and by far the largest and strangest. Many people are crazy about the search for extraterrestrial life, but this was different. This felt real. The news shot through the astronomical community like a shockwave. Comets from our own solar system drift in on lazy, looping paths. This one came from deep space, an origin written in its unbelievable velocity. Initial estimates put its diameter between 6 and 18 miles, making it the biggest interstellar tourist we've ever seen. What many overlooked in the initial excitement was its brightness. Even at nearly 420 million miles from the sun, it was already reflecting far more light than it should have been. The object's trajectory wasn't just open, it was a nearly straight shot, tracing back toward the ancient, dense disk of the Milky Way. This discovery was a statistical bombshell. The last time humanity spotted an interstellar visitor was 2I Borisov in 2019. Before that, only the bizarre Oumuamua in 2017. Now a third one in less than a decade? The odds seemed almost impossible. With its designation confirmed, a global scramble began. Every major observatory pointed its instruments at the new arrival, racing to capture any hint of its composition. The raw numbers left astronomers both thrilled and deeply uneasy. The real anomalies, however, the ones that would push science to its absolute limits, were still hidden in the data. The trajectory alone was enough to raise red flags. It was traveling almost perfectly along the ecliptic plane, the flat disk where all our planets orbit. The odds of a random visitor from another star system threading that needle are less than 1 in 500. And then there were the planned planetary encounters. Mars, Venus, and Jupiter each pass within tens of millions of miles. It was a kind of cosmic tour that seemed far too precise for mere chance. The usual models couldn't explain why 3I Atlas was so big, so bright, and moving so fast on such a perfect path. To put it mildly, the classical tools of physics were failing. That's when the talk began about feeding this impossible data into a new kind of system, a quantum AI. A new kind of intelligence was needed to understand this visitor. A tale of lies. Classical computers have been the workhorse of astronomy for decades, but they hit a brick wall with 3I Atlas. These machines work step by step, calculating one possibility at a time. But the data from this object kept branching into a chaotic mess of outcomes. The more variables they added, solar wind, outgassing, non-gravitational forces, the worse the problem got. It was a combinatorial explosion. Even the world's mightiest supercomputers couldn't keep up. You see, the problem wasn't just about speed, it was about seeing every angle at once, something only a quantum computer can do. Scientists at NASA's Quantum Artificial Intelligence Laboratory decided to take a radical step. They fed every scrap of data into a hybrid quantum system powered by 124 specialized GPUs, hardware normally reserved for creating the world's most advanced AI. Instead of calculating one path, the quantum AI explored millions of possible timelines simultaneously. It was like flipping a coin and having it land on both heads and tails at the same time. The simulation, which would have taken weeks on a normal supercomputer, finished in minutes. The results started with the object's chemistry, and it was deeply wrong. On August 12th, the James Webb Space Telescope found that the coma, the fuzzy halo around 3I Atlas, was venting carbon dioxide at an astonishing rate, over 280,000 pounds every second. But here's the wow factor. For every 8 parts of carbon dioxide, there was only 1 part water. In our solar system, comets are dirty snowballs driven by melting water ice. This object was something else. It was an anti-snowball. The most shocking fact is that the venting wasn't a steady stream. It came in short, controlled bursts, timed perfectly with the object's 16.8-hour rotation. It was as if a set of powerful vents were opening only when facing the sun, like a pressure valve, not a melting ice cube. Some researchers whispered the term artificial modulation. The AI simulation agreed, flagging these emissions as statistically closer to an engineered system than any natural comet in its vast database. The tail itself was another puzzle. It wasn't a diffuse cloud of dust, it was a tight, focused column like the exhaust from a jet engine. Even stranger, spectroscopy detected nickel in the tail, but almost no iron. In nature, nickel and iron are cosmic twins, always found together. Finding one without the other is a massive red flag. Nickel is a key component in high-temperature alloys used for heat shields and propulsion systems. The data pointed to one chilling conclusion. The tail wasn't just debris, it was an engine. Checkpoints in the dark. The numbers that came back from trajectory analysts at NASA's Jet Propulsion Laboratory were, frankly, unbelievable. After speeding through the inner solar system, 3I Atlas was projected to pass just under 18 million miles from Mars on October 3, 2025. 4 weeks later, it would sweep 60 million miles from Venus. Then, on March 16, 2026, it would pass within 33 million miles of Jupiter. For an object from another star, this geometry is beyond strange. It's borderline impossible. What many overlooked is that the timing of these passes seemed choreographed. The flyby of Mars was scheduled for when the planet was on the same side of the Sun as us, making it easy to observe. The passes by Venus and Jupiter were similarly optimized. The odds of a random object from deep space threading a path this precise, hitting 3 planets in such a coordinated sequence, were calculated by a Monte Carlo simulation. The result? Less than 1 in 20,000. It was as if our solar system was being systematically surveyed planet by planet in a single efficient flyby. The quantum AI took this probability analysis to a whole new level. It ran millions upon millions of simulations, letting every variable float: velocity, angle, gravitational nudges. And still, the result barely changed. The probability cloud kept clustering around the same impossible set of close planetary passes. In these simulated universes, only a tiny handful produced the same chain of encounters without some form of deliberate directed input. The analysts even ran the integrations backward, looking for any natural cause, like a past gravitational assist from another planet, that could explain this bizarre tour. They found nothing. The trajectory was clean, arriving from the direction of Sagittarius at an incredible speed. Too fast to be captured by our sun, too straight to be local debris. The thing nobody tells you is how this compares to past visitors. Oumuamua and 2I Borisov cut through our system on paths that, while unusual, didn't feature this kind of planetary choreography. They were cosmic loners passing through. 3I Atlas, on the other hand, behaves like it's following a map. The geometry suggests intent. If these numbers are right, 3I Atlas isn't just a visitor, it's on a mission, treating our planets like waypoints. The probability of this happening by chance is so astronomically low that it forces you to consider the alternative. The simulation had one final, terrifying number to deliver: a relic or a threat. The quantum AI's final output wasn't a simple yes or no. It was a cloud of probabilities, a map of every possible reality for 3-eye Atlas. At the very center of that cloud, one number made the room go silent, less than 5%. That was the chance the simulation assigned to 3-eye Atlas being a natural object, a random chunk of rock and ice tossed from another star. You see, this means there was a 95% probability that it was something else entirely. Every other branch in the simulation pointed toward a conclusion that was far more disturbing. Some outcomes in that 95% suggested it could be a derelict craft, something ancient and lifeless coasting on a path set billions of years ago. But more than half of the simulation's most likely scenarios landed on a far more chilling possibility: active modulation. This implies controlled emissions and deliberate course corrections that can't be explained by random outgassing. The AI weighed every data point: the impossible trajectory, the engine-like emissions, the close planetary passes, and each time the odds of pure chance dwindled. The AI's verdict came with a stark warning. If 3-eye Atlas is acting under its own guidance or even remote control, the entire risk profile changes. The difference between a dead relic and an active probe is the difference between an archaeological find and a potential weapon. And in the vast landscape of possibilities mapped by the AI, the branch where 3-eye Atlas is just a dumb rock moving by luck is the thinnest, most improbable one of all. This is the moment where science fiction bleeds into reality. Many people watching this are probably grappling with a profound sense of disbelief. They're wondering if this could all truly happen overnight, if the scenario unfolding before them is genuinely real. Is there some crucial detail we are missing? Is there a flaw in the model, a miscalculation that will bring us all back from this precipice of fear? The difficult truth is, the data is the data. The simulation doesn't operate on narrative or bias. It doesn't offer explanations in comforting words or provide a hopeful alternative. It just shows the numbers, orbital mechanics, mass, velocity, and trajectory, leaving the terrifying implications to hang heavy and suffocating in the air. This cold, impartial presentation of facts forces us to confront our own deep-seated vulnerability, a fragility we spend our entire lives trying to ignore. To understand the scale of our blindness, we need only look back to a recent and, by cosmic standards, minuscule event. In 2013, a rock just 65 feet across, the size of a small building, entered the atmosphere and exploded over Chelyabinsk, Russia. The resulting shockwave injured over 1,600 people, shattered windows, and collapsed roofs. It was a stark reminder of the energy packed into even a modest asteroid. And crucially, nobody saw it coming. It arrived out of the morning sun, completely invisible to our warning systems. Now, consider the object in question, 3-eye Atlas. It is not merely larger than the Chelyabinsk meteor, it is hundreds of times more massive. This isn't a simple linear increase in threat, it's an entirely different category of existence-ending power. If an object of this magnitude and composition were aimed at Earth, our current planetary defense systems would be little more than a prayer whispered into the void. Our most advanced concepts, like kinetic impactors, require decades of advance warning to successfully alter a trajectory. Confronted with a short-notice threat of this scale, our technology becomes a monument to our own hubris. The ultimate horror, then, is not simply that something alien and vast is here, encroaching on our tiny, safe corner of the universe. The true soul-chilling terror comes from the sudden, stark realization that our shield against the cosmos, the intricate web of satellites, telescopes, and defense strategies we believed kept us safe, is more fragile and illusory than we ever allowed ourselves to imagine. For generations, we operated under a profound delusion of control, pointing our instruments outward with the confidence of masters cataloging their domain. We built protocols for asteroids and wrote papers on distant stars, all while resting on the comfortable bedrock assumption that the fundamental laws of the universe were known and predictable. That bedrock has now crumbled into dust. The systems we built were not a fortress wall. They were a child's sandcastle, waiting for a tide we refused to believe was coming. We are not the masters of our domain. We are inhabitants of a glass house in a universe that is constantly throwing stones. The most terrifying part is the dawning awareness that we never even saw the arm that threw them. The silence that follows is not one of peace, but of profound existential dread. We are left staring out into the same sky, but it is no longer a frontier of discovery. It is an abyss staring back, reminding us that our greatest accomplishment was merely a temporary illusion of safety. So is 3i Atlas a messenger, a scout, or just a cosmic coincidence of impossible odds? Let us know what you think below. Like and subscribe for more deep dives into the unknown.